Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the VCE 2025 Physics Examination. In this VCE Physics exam, more than 1/4 of all students scored 0 marks on a seemingly simple question about a magnet dropping through a solenoid. It wasn't because they didn't know the physics, it was because they used vague wording like the field changes. Today, I'm going to show you the exact marking triggers the examiners look for so you never leave easy marks on the table. The interaction. As the magnet falls toward the solenoid experiences a change in magnetic flux. The physics law. According to Faraday's law, this rate of change of flux induces an EMF in the solenoid. The circuit. Since the solenoid and ammeter form a closed circuit, this EMF drives an induced current. Usually, a 2-mark question like this is clumped in the marking center. Mark 1. Identifying the change in flux occurring specifically within the solenoid due to the magnet's motion. Mark 2. Linking that change in flux to Faraday's law to explain the induction of EMF a current. Avoid the 0-mark phrasing. As the examiner's report noted, wording is everything. Here is a quick translation guide. Avoid saying, the magnet's field changes. Instead say, the flux through the solenoid changes. Reasoning, the magnet's field is constant, the intersection with the coil is what changes. Avoid saying, electricity is created. Instead say, an EMF and current are induced. Reasoning, use formal VCE terminology for electricity. Avoid saying, Lenz's law says it opposes. Instead say, Faraday's law says changing flux induces EMF. Reasoning, Lenz's law explains direction, not the existence of the current. The ammeter is replaced with an oscilloscope. The measurement of induced EMF versus time, shown in Figure 14, is recorded as the magnet falls. Note there is a large negative induced EMF spike at A, and an even larger positive induced EMF spike at B. The magnitude of the maximum induced EMF of the spike at B is both opposite in sign to, and larger than, the maximum induced EMF of the spike at A. Explain. 3 marks. Marker 1. Direction assign. As the magnet enters the solenoid, A, the magnetic flux is increasing. As it leaves the solenoid, B, the magnetic flux is decreasing. According to Lenz's law, the induced EMF must oppose these opposite changes in flux, resulting in opposite signs for the EMF peaks. Marker 2. Magnitude of velocity. Because the magnet is falling under gravity, it is accelerating. It therefore has a greater velocity when exiting the solenoid, at B, than when entering it, at A. Marker 3. Linking to Faraday's law. According to Faraday's law, the induced EMF is proportional to the rate of change of magnetic flux. The higher velocity at B causes a more rapid change in flux, resulting in a larger maximum EMF magnitude than at A. Examiner's trap, the symmetry error. In VCE exams, students often correctly identify that the magnet is faster at the end, but fail to explicitly state why that leads to a larger EMF. They must link the higher velocity to a higher rate of change of flux. Feature of spike B, opposite sign, physics justification, opposing, an increase versus a decrease in flux, key terminology, Lenz's law. Feature of spike B, larger magnitude, physics justification, magnet is falling faster due to gravity, key terminology, rate of change of flux. Feature of spike B, narrower width, physics justification, magnet spends less time exiting than entering. Key terminology, delta T is smaller. Denzel is using a demonstration hand-cranked generator. A schematic diagram of the generator is shown in Figure 17. The generator contains a rectangular coil with side lengths of 5.0 cm and 2.5 cm, consisting of 20 turns of insulated copper wire. The coil is rotated between two bar magnets that provide a field strength of 0.60 T between the magnets. Denzel rotates the coil at a frequency of 50 Hz. State why the flux through the coil changes as the coil rotates. 1 mark. Refined response. As the coil rotates, the angle between the magnetic field lines and the area of the loop changes, which causes the component of the magnetic field perpendicular to the area of the coil, or the effective area, to change. Common pitfalls for students. Unit conversion errors. Students often forget to convert centimeters to meters. Always use standard SI units, 0.050 m and 0.025 m, before calculating the area, to avoid power of 10 errors. Flux versus flux linkage. The question asks for the flux through the coil, not the total flux linkage. Including the number of turns in this specific calculation will result in an incorrect answer. Orientation confusion. When the coil is horizontal, as shown in Figure 17, it is parallel to the magnetic field, meaning no field lines pass through it. When it rotates to a vertical position, it is perpendicular to the field, and the flux reaches its maximum value. Strict adherence to significant figures, 2 SIG figs. In VCE Physics, your final answer must match the precision of the data provided in the stimulus. Since the side lengths, 5.0 cm, 2.5 cm, and the magnetic field, 0.60 T, are all given to two significant figures, steps should reflect this. Step 1. Calculate the area, A. Step 2. Identify flux at positions. Vertical position. The coil is perpendicular to the field lines, so flux is maximum. Horizontal position. The coil is parallel to the field lines, so no field lines pass through the loop. Step 3. Calculate the change. Step 1. Time interval. The period of rotation T, for a 50 Hz frequency, is the reciprocal of the frequency. Since the coil rotates through only a quarter turn, the time interval is. Step 2. Faraday's law, using the change in flux from part B and the number of turns. Step 3. Final result. To avoid the common errors mentioned in the examiner's report, encourage students to follow this checklist. Check the turn. Is it a full turn, T, half turn, T2, or quarter turn, T4? The 0.02 error shows students often jump straight to the period without reading the quarter turn constraint. The N factor. Remind them that while flux doesn't use N, EMF always does. Two significant figures. Since the input data is given to two significant figures, the final answer must be recorded as 3.0 V. Writing just 3 or 3.00 could result in a rounding a precision penalty. Change. Replace the slip rings with a split ring commutator. Reason. A split ring commutator reverses the connection of the coil to the external circuit every half turn, when the induced EMF reverses direction. This ensures that the current in the external circuit flows in only one direction, producing a DC output. Terminology alert. Ensure students do not confuse slip rings AC with split ring DC. In a 2-mark question, using the wrong term will likely result in 0 marks, as the reason will no longer match the change. 1. The mechanics of induction. Flux change. Induction occurs because the amount of field passing through the loop changes, via motion or rotation, not because the magnet's field itself changes. Faraday's law, induced EMF is proportional to the rate of change of flux. Circuit requirement. An induced EMF only drives an induced current if the circuit is closed. 2. Analyzing the EMF time graph, oscilloscope spikes. Sign Lenz's law entry, increasing flux, and exit, decreasing flux, induce opposite EMF signs to oppose the change. Magnitude, Faraday's law because the magnet accelerates under gravity, it exits faster than it enters. Higher velocity induces higher rate of flux change, consequently larger EMF peak. 3. Calculation and generator precision. Effective area, rotation changes the angle, altering the perpendicular component of the field lines through the coil. Unit SIG Fig discipline, always convert cm to m. If data is given as 0.60 T or 50 Hz, the final answer must reflect two significant figures. The quarter turn trap, 450 Hz, T equals 0.020 s. A quarter turn is 1/4 of a period. 4. AC to DC conversion. The switch, replace slip rings, AC, with a split ring commutator, DC. The logic, the commutator reverses the coil to circuit connection every half turn, keeping external current flowing in a constant direction. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.